We come to page 45. Now we are doing working on the we work on chapter 6 today, and the difference between chapters 4 and chapter 6 is this. In chapter 4, we determine in the problems in chapter 4 we determine the support forces, right? In chapter 4, like the problem 4.7. Like in sample problem 4.7, we determine support forces. And now in chapter 6, we are doing we will work on determining internal forces in structures. So in chapter 4, we always say in a three-point diagram. In a three-point diagram, we only have external forces, right? Let me go to the thing in front for a minute. And in this frame that we only determine in the three-point diagram, we only draw external forces. These external forces and internal forces, we do not write forces on them, right? We do not put forces on them. But now in chapter 6, we want to determine the internal forces in structures, okay? We want to determine the forces in structures. Now, and for determining the forces in structures, we begin from a simple structure. And for this kind of structure, we call it a truss. And in Chinese, it is this one. Okay? It is this one. So your spaghetti bridge would look like a truss usually. Now, I would go through this trusses have these properties. Like so in this truss, the truss means the whole structure. Okay, the whole structure is called a truss, and each bar in the truss is called a member. If you look up at the dictionary, that it means if you look up a dictionary, it is this one. But you know what I mean. Now, here we have how many members do we have in this truss? So it has it looks like a triangle and one member there. But in a truss, for this part, we always say we have two separate members. Okay, we have members AC and CB, but we do not have ACB. Okay, we have two members. One member is AC and one member is CB. Okay, so we will not say we have ACB. We have only AC and we have CB. In complete sentence in English, so members are straight connected to others at ends only. So this part is connected to others at the ends. So these are straight is 直哈。 and connected to others at the ends only. So these are straight and connected to the ends only. The second thing is what we say here is we do not ACP. When we have only AC and CP, this means members do not go through joints. Okay, members do not go through joints. So if we say we have AC for this line ACP, it means go through joints because we have the joint C here. So we have only AC and we have CP, and we do not have ACP. Now, by putting these two together, so we have one member here, two member here, three member, four members, and five members in this trust. For each member, can we what kind of structure it is? We have learned two terms on Tuesday. We have learned two terms on Tuesday, which are what? Let's go back to page. Let's go back to page 40. Let's go back to page 41. And what have we learned on Tuesday? We have two force bodies and three force bodies. All right. We have learned on Tuesday we have two force bodies and three force bodies. So if we say that it has only two ends and it is connected to others at the ends only, and it do not go through joints. So what kind of structure it is? Two force body or three force body? So we have AP and DP and AC and CP and DC. What are these structures? Two force bodies, okay? All members in a trust are two force bodies. It's okay. All members are two force bodies in a trust. And if we have forces acting on a trust, we will have all of them act on joints. So, for example, we have P here, and or we have B here, but we do not have forces here. We do not have forces here. We can only put forces at joints. Okay. We can only put forces at joints. And so, for example, if this rod has a weight of like 100 Newton, 10 kilogram, 100 Newton. So, how do we put that force? How do we put that force in the diagram, in the truss? For example, if it has 100 Newton, or let's say 10 kilogram. So how can we put this? How can we consider this force? Consider is how do you? How can we put it? Put this self weight onto the figure. So we put if we have 100 newtons as self weight, and we cannot put it there. So what do? We put 50 newton to the left, and we put 50 newton to the right. It's okay. If we have a mass of like 100 newtons. Okay. So if in a question, if I tell you that it has a weight of like 100 Newton or 200 Newton, that you put half of the weight to the left and half of the weight to the right. And the last point I want to talk about is that all joints on the truss are pinned. It means this means all for two members AB and AB here, that they can rotate about each other. Pin. We have pin joint here, so they can rotate about each other. Okay. Now, before we end today's lecture, and we have sometimes you will come across a term called simple trusses. For simple trusses, it means that it is a rigid body if supports are removed. Like this one is a rigid body because this is fixed, but the one below is not a rigid body. This is not a simple truss. Because this one is pinned. All joints on the truss are pinned, so if we remove the support, remove is so if we remove the support, then these two parts can rotate about each other. So this is not a simple truss. For a simple truss, like the one above, that after removing the support, that it is still a rigid body. So this is what I a short introduction to trusses, and I will continue on Tuesday.